Today we're going to focus on interpreting the domain and the range of trigonometric and logarithmic functions. I've got 4 examples to show you. My first one is f of x equals the cosine of x. It's our nice little wavy graph. If we are looking at the domain, we're looking from left to right. So we're looking at the x's. If we're looking for the range, we're looking for how low does the graph go to how high does the graph go. We could also pull up a chart, and so I'm going to remind you how to do that in Desmos. Let me make it look like the one we have. So we've got f of x equals cosine of x. If you also want the chart to come up so you can see x and y values, then you hit the wheel and then you hit the chart icon, and you'll get a nice little chart with usually 5 points. Somewhere around where the y-axis is, probably 2 negatives, 2 positives, and 0. And then I think you could probably add in x's here, and you could put in more x's. So if you wanted to know, what this graph was doing when x was 6, you could actually add in x's there, or you could do smaller x's. So that's where I am getting the chart from Desmos. So again, we're looking at our x's. We'll talk about our x's. We'll use red to denote our domain. Our x's are how far to the left the graph goes. And since this graph continues to the end of the viewing window on our grapher, we can add an arrow here. We can also add an arrow on the right-hand side. So our domain is going to go from x's that are negative infinity. The graph is continuous all the way to where x's are positive infinity. So our domain would be negative infinity to positive infinity. You could also see that written as all real numbers. When we look at our range, we're looking at our y values. We're looking at how low the graph goes. So this graph goes down to -1, and it goes up to +1. It doesn't go any lower than -1. It doesn't go any higher than +1. I don't have any visible open circles, so I would use a bracket for the domain here and say our x's include -1, and they go to all the x's, include all the x's between -1 and +1, and we also include 1, again, because these are closed circles. We don't have any open circles. All right, let's take a look at the next example. It's a sine graph. F of x equals 4 sine of x. Again, if we're looking at our domain, we're looking at our x values. So we're looking at how far the graph goes to the left and how far the graph goes to the right. This graph is continuous, just like the cosine graph. So our x's are going to continue to negative infinity, and they're going to go all the way to positive infinity. There are no pieces to this graph. There are no vertical asymptotes that are stopping the graph from having all x values between negative infinity and positive infinity. So there is my domain. My y's, again, are my range. It's how low my graph goes. So my graph goes all the way to -4, and it goes all the way up to +4. Again, no visible open circles here, so we'll use a bracket, not a parentheses, and we'll say our y's, our range, includes all the y values from -4, including -4, all the way to +4. So all those decimals, whole numbers, and fractions that lie between -4 and +4, we have a point that has all of those y values. All right, our next example is a log function. F of x equals log of x. Log functions usually have vertical asymptotes, so I'm going to draw in an imaginary vertical asymptote. I'll use pink here. If we were actually in the Desmos grapher, you could zoom in and you could actually see that this graph bends but does not touch the y-axis. So we actually have a vertical asymptote here at x is equal to 0. So if we're looking at our domain, again, that's our x's. We're looking at how far to the left the graph goes to how far to the right. Our graph goes all the way up to where x is 0, but it doesn't actually get to 0 because of that vertical asymptote, and then it does continue to positive infinity on the right. So our domain is going to be parentheses this time because our graph's not going to touch the y-axis. So we're not going to have an x value of exactly 0, and then the x's are going to travel to positive infinity. Our range, our y values, this graph, let me grab my red. This graph actually continues. It kind of got blurred in with the pink, but it continues like this, prettier than what I just drew in. but the graph is going forever down. So that means that my y values here are negative infinity. And then as the graph continues to rise, even though it's rising slowly on that right-hand side, it is going to finally reach positive infinity if we let the graph go far enough. So my range is going to be parentheses, negative infinity to positive infinity. And lastly, let's take another look at a log function interpreting domain and range. I'm going to go ahead and draw in the vertical asymptote. That is just something that I'm drawn to first. So I see that this graph is bending towards a vertical asymptote where x is 2. So again, the graph doesn't touch this. It looks like it does, but if we were in Desmos or our TI-84 calculator and we zoomed in, it's not going to touch. It's going to bend and just get closer and closer. So if we're doing our domain, again, that's our x values. So we're not over here at the y-axis anymore. Our asymptote is at 2. So our x's are going to go from 2 to infinity. Again, parentheses at 2 because of that asymptote. Our graph's not going to touch, not going to have any points where x is 2. And then our range are our y's. So this graph's going to go forever down. And then slowly it's going to go forever up. So range is negative infinity to positive infinity. Hopefully that helps us interpreting domain and range of trig functions and log functions.